All right, so yesterday we found equations of lines, we graphed lines, reviewed all that. One thing we didn't get to yesterday was word problems involving lines. So word problems are real life situations where a line may be something that is necessary. If you're not sure what the pieces of the information in your word problem represent, this slide is helpful. In real life, a slope represents something that is constantly increasing or decreasing. If it's constantly increasing, your slope is a positive number. If it's constantly decreasing, your slope is a negative number. In real life, a y-intercept represents a starting place, a base amount, an initial value. Think about when we made the graphs yesterday. The y-intercept was the place that we started our graphs. It's where our x value is equal to 0 and x value is an initial value if it's 0. And then finally, coordinate pair, you might be given a point in your word problem. I don't know what's happening next door. We're just going to ignore it. You might be given a point. So if you have two pieces of information that go together, that represents an x and a y on a point in your line. You just have to maybe decide what's the x and what's the y. Remember, x is always an input, what you're starting with. Y is always an output, what you're ending with. So input, output, sometimes we use the words independent, dependent, if you've heard those before. Okay, so slope is our rise and our run, our increase, our decrease. Y-intercept is a starting amount, coordinate pair, or two pieces of information that go together. Okay, so we're going to start with two word problems. We're going to do the first one together at the top. Okay, these can be a little tricky. I pulled these straight from Math Excel, so you will likely see problems like this on your Math Excel when you guys get to 2-3. All right, in 1995, Orlando, Florida, it was about 175,000 when it was the population. At that time, the population was growing at a rate of about 2,000 per year. We're going to write an equation in slope-intercept form to find Orlando's population for any year, and we're going to let x equal the years after 1990. Then we're going to use our model to predict the population in 2027. So model is a fancy word for equation. We're going to write an equation first. That 2027 piece, we'll do that at the very end. First thing we need to do is kind of just decipher what all these numbers mean. So let's start with, I always start with the slope if I can find that. Do we have a slope in this problem? Just say it. What is it? 2,000 in my slope. And is it a positive or a negative slope? How do you know it's positive? Because it's growing. It's going up, not down. Okay, so we have a slope. So now I've got one of two other things in this problem. I either have a y-intercept, and then I'm set, or I have a point. What do I have here? Here's why it's not a y-intercept. If this said years after 1995, 1995 would be the starting amount, the starting year, and you can use that number for your y-intercept. But we're not starting in 1995, are we? We're starting in 1990. So because we're starting in 1990, 1995, and what was that other number? 175,000, that's a point that go together. So we're going to write our coordinate. If you're not sure what's an x and a y, time is always an x. Time does not depend on anything else. It is independent. So my time is 1995. Now, when we write our x's represent years after 1990. So if I'm in 1995, how many years after 1990 was that? That's my x. 5 years after 1990, my population is 175,000. Now, can you use those two pieces of information to write an equation? It's just like yesterday now, right? We just kind of have to decipher those pieces, but after this, we can go straight to our y equals mx plus b and plug in what we know. We know my slope is 2,000. My y is 175,000. My x is 5. 5 times 2,000 gives me 10,000 plus b. Subtract 10,000. 165,000 is b. So that's the population in 1990. That's our starting amount if you were to have a question about that. So our final equation is y equals 2,000x plus 165,000, the population in 1990. Okay. And now it says use your model to predict the population in 2027. We are not going to plug in 2027 for X. What are we going to plug in for X? What do you think? 37, because again, X is years after 1990, and 2027 is 37 years after 1990. You can always subtract those two. So we're just going to plug in 37, and you're going to need a calculator for that, likely. And I don't know what that is. Let's see. $239,000 is the population. We're going to get in the habit of labeling whatever something represents in a word problem, people in this case. Okay, questions on that one? Okay, second one I'm going to get you started on and let you guys finish it with your partners. It says it's 76 degrees at a 6,000 foot level of a mountain, and then it's 49 degrees at the 12,000 foot level. So those are our elevations. Write a linear equation in slope-intercept form to find the temperature T at an elevation of X on the mountain, where X is thousands of feet. Then use your model to answer a question. Okay, so first things first, I want to point out we have certain variables that we are supposed to use. Some of you have already learned this in Math Excel, right? They give us a certain variable. We have to use that certain variable, otherwise it's going to mark it wrong. So elevation is X, which means temperature T is replacing our Y in this problem. Also, X is thousands of feet. So if I have 6,000 feet, what X do I use? Just 6, and then it's implied that it represents thousands. And it's telling me that's the X and Y. So you don't actually in this problem have to guess what's X and what's Y. They're telling you X is the elevation. So 6,000 feet goes with 76 degrees. That's a pair of information that goes together. And then the same with our second elevation, 12,000 feet. I have a temperature of 49 degrees Fahrenheit. Is that enough information to write the equation of a line? All right, so with your partners, I want you to finish this problem. Write an equation, make sure there's a T in it, not a Y, and then answer what's the temperature going to be at 15,000 feet. Go ahead. Okay, let's see how you did. If you got 35.5, you're pretty good. Slope, plug in the slope with one of your points. Get the y-intercept 103, yes. So that's a tough one because normally fractions are preferred in this class. But here's a good question. Would you ever tell somebody that the temperature outside is 71 over 2 degrees Fahrenheit? Probably not. So there are occasions where in a word problem, that's a good question, it's appropriate to give a decimal. Even a rounded decimal would be okay because it's temperature. You'd probably just round to like the nearest whole number. You wouldn't tell somebody it's like 71.67 degrees or something like that. You know what I mean? So word problems are going to be the exception, depending on how you get that answer, okay, to someone. Make sure you have a T at the end of it. It's also nice with word problems, too, that you should expect a type of reasonable answer. You can look at this problem and be like, all right, at 6,000, it's 76 degrees. And then it got higher, 12,000, and the temperature went down. So at 15,000, should we expect a number bigger or smaller than 49? It's going down. So if I got an answer of like 72 degrees, that's wrong. Right? Because that's not the trend in what's happening in this situation because it's linear because that's the case. So that's the nice thing about word problems is you're going to get answers that are reasonable, and if they're not reasonable, then we got to get something on to go back and check for. Okay? All right. Next thing we need to review about lines. What do you know about parallel lines? They don't touch. Slopes are the same. Okay, what do you know about perpendicular lines? 90-degree intersection. Slopes are opposite reciprocals. Okay, so for example, if I have a slope of 2/3, what's the opposite reciprocal of that? -3/2. So we flip it, we change the sign. If you're not sure if two numbers are opposite reciprocals or not, multiply them together and you get -1. If I multiply 2/3 times -3/2, my answer is -1. Now the reason we want that in this class is because it won't always be fractions. It might be radicals that you're looking at, and it's difficult to tell if you have an opposite reciprocal or not. So if you multiply them together and you get -1, they're opposite reciprocals. Okay, so now that we know that, or we've reviewed it anyway, that's the little statement up there if you want to write it down. I've got two pairs of lines. In each pair, let's think of this like a multiple choice question. I want you to determine if this pair is parallel, perpendicular, or neither. And the same with this one. Parallel, perpendicular, or neither. That answer can be determined by just finding the slope. Okay, so if you find the slope of all four lines, compare each pair, and that should tell you parallel, perpendicular, or neither. I'll give you a few minutes to try them with your partner. All right. So, first of all, hold on. Okay. So, x equals -1 is what kind of line? Vertical. It's a vertical line. Its slope is undefined. Does that mean our answer is undefined? No. Slope of undefined does not equal line undefined. Those are not the same thing. Okay, so this is undefined. Now this one was tricky. Is there a y here? No. So could I get an x alone and make it look like x equals a number? Yes. Sure. Also a vertical line, also undefined. If I have two vertical lines, how are they related? They're parallel. What if you have two horizontal lines? Parallel. What if you have a vertical and a horizontal line? Perpendicular. So those are our special cases. Over here, I get my y alone. Number in front of the x is my slope, -2. Slope here, that guy's already alone, 1/2. And then if you want, you can either see the fact that they're opposite reciprocals, or you can multiply them together to get -1, and that tells you they're perpendicular. These are symbols if you want to use them. Parallel, perpendicular. Write down C. Questions on parallel, perpendicular? Great. Okay. We're going to do these two problems together. Find the equation of a line that passes through the point 6, -2, and is parallel to x equals 5. Okay, so x equals -5. What do we know about that? It's vertical. And its slope is? Does an undefined slope mean the line is undefined? No, okay? So we're just going to keep in mind we have a vertical line. And we want something parallel to a vertical line. What else is parallel to a vertical line? Another vertical line. So what's my answer going to look like? X equals something, and I wanted to go through that point, so x must equal 6. Now what if I change this problem and instead of parallel to x equals 5, I said perpendicular to x equals 5. Ooh, you guys are fast. So if I want it to be perpendicular to vertical, it's got to be horizontal. Y equals a number, and it's got to go through that point, so y equals -2. Those are our special cases. All right, let's look at the one at the bottom. Perpendicular to 5x minus 3y plus 4 equals 0, and passing through the point 8, 4. Okay, so these are not special cases. We're just going to work with what we got. If I see the word parallel or perpendicular in a problem, what's the first thing I should try to calculate? Slope of that line. So how do I calculate the slope of that line? Y alone. So yeah, we can take that 3y and just move it over to the right. 5x plus 4 equals 3y. And then divide by 3. So 5/3 x plus 4/3 equals y. What's my slope? 5/3. Is that the slope I'm going to use in my answer? No. Why am I not going to use 5/3? I need the opposite reciprocal, which is what? -3/5. Now, if the problem said parallel, I would just use the 5/3. So it's actually one less step if you see the word parallel. But other than that, it's going to be identical. All right. After this now, it's the same as yesterday. So y equals mx plus b. M is -3/5. X, I want to go through that point, is 8. Y is 4. What is -3/5 times 8? -24/5. 4 is the same as 20/5 plus 24/5 is 44/5. And fifths are something that you could give a decimal for and not have to round it. But we like fractions in here, so why not? Right? Final answer. Yes?
Wait, so like if the y equals -2 and x equals 5 are perpendicular, does that mean that 0 times undefined is a -1?
0 times undefined is -1. Could be. I mean, we can't actually do that calculation, but undefined, we're going to talk about later in this class, is the reciprocal of 0. When you have 0, it's because if you do the slope, like the difference in the y's divided by the difference in the x's, 0's in your numerator of your slope formula and some other numbers in the denominator. So let's call 1, okay? If I have an undefined slope, it's because 0's in the denominator. So could I do that and get -1? Sure. Do we do that calculation? No. We just know that 0 and undefined are going to always be reciprocals of each other because of the location of our zeros when we do our slope formula. Okay? So yes. All right. Other questions? Okay. The last thing I have for you today, you need your graphing calculator for. If you don't have yours, that's okay. You can just share with the friend next to you. Let me get mine. There's mine. All right. We are going to use our calculator to make a scatter plot and the line of best fit that goes with that scatter plot for this information. So here we're comparing number of absences in a class to the final grade of that class. All right, so first thing we're going to do is we're going to hit stat. It's in red there. It's right next to my arrows. Okay. Then we're going to hit enter to edit our data. Okay, now mine's already in there. You obviously don't have it in your calculator yet. First thing we want to check, does everybody have an L1 and an L2?
Yeah.
Does anybody not have L1 and L2? Speak now, please. We're good? Okay. If you have stuff in here, here's how you get rid of it. You go up to the list name, so highlight like list 2. Then you hit clear, then you go back down. Okay, so go up to the list name, hit clear, not delete. Delete is bad, don't delete. Clear and back down. Okay, and then go ahead and take a minute and put this data in there. Okay, so your L1 column represents your x's. It should be all the numbers from 0 to 9. L2 is 89.2, 86.4, 83.5, 81.1, 78.2, 73.9, 64.3, 71.8, 65.5, and 66.2. Good? Okay. Next thing we're going to do is we're going to calculate the line of best fit, and then we'll graph it in a minute. We're going to hit stat again. Then we're going to go over to where it says calculate, and we want a linear regression. That's a fancy word for the line of best fit. So if you look at number 4, that's our line, and our calculator uses A instead of M, but that's really representing an mx plus b, which is what we want, slope-intercept form. So we're going to choose number 4. It should say next to X list L1 and Y list L2. Does everybody have that okay? And then we're going to go down to where it says calculate. There we go, and hit enter. And then it's not really important right now if you have the R's also, but you should have an A value of -2.83-ish and a B value of about 88.73. Okay? If you don't have those numbers, but it's really close, it's just because you typed in a data value wrong. So you just want to go back to your list and check it. Okay, so we have the line of best fit. Usually, if you're pulling it off of your calculator, you want to give it at least 3 decimal places. So it's telling you A is the number that goes in front of the X and B is the Y-intercept. So it's going to be negative 2.827 with my X plus 88.733. They give it 3 decimal places. Did you guys talk about R's in Algebra 2 correlation coefficients? So we don't really get a lot into this. Like if you take a statistics class, we do more with it. But this number bounces between -1 and 1. The closer it is to -1 or +1, the better the line is that fits the data. Does that sound familiar? So this is pretty close to -1 if your calculator shows this number, which if it doesn't, it's not a big deal, like I said. But it's pretty close to -1, so that says there's a pretty strong correlation. This is going to be a pretty good fit for this data. Okay, to see the picture of it now. Back to our calculator. We're going to go into y equals. In y1, I want you to type the equation we just found. Move that over a little bit. In y1. And then I want you to turn your plot on. My plot is on because it's highlighted. If your plot is not highlighted, it's not on. So you go up, hit enter to highlight it, and go back down. Okay, so we turn our plot on, put our equation in y equals. All right, everybody have a plot on equation in y equals? That plot, turn back off if you're just graphing normal stuff. Sometimes if the plot's on and you're trying to graph other things, the calculator gets confused and it gives you an error. So we only want that plot on if we're doing like scatter plots and stuff. Not just turn it right back on. All right, now we want to see the picture. If you go to your normal window, you're probably not going to see it because we have specific set of data and numbers that we need to zoom in on. So anytime we're doing a scatter plot, we're going to hit zoom in the middle at the top there. And then normally zoom 6 is your standard normal window. If you're graphing statistics, we use zoom stat, number 9. And you're going to do that every problem because your data is going to change every problem. And you should see this picture. If you have this picture, you're good. Raise your hand if you do not have this picture, and I will help you troubleshoot. Okay. You don't have. Oh yeah, plot on.
There we go.
Oh, -2. That's all it was. Invalid dimension.
Check size.
Okay. I don't know. Usually it's a pretty easy fix. I mean, I want to be able to Yeah.
Oh, yeah, because like you can go through.
But basically, but it's like a senior but most of the time, yeah, it's like, I don't know about this year, and then what's that band, and you specify, like, no,
Your math teacher. Okay. Yeah. So, okay, you can do whatever you want there. So now I'm just gonna.
I tried, but.
I did it like, I'm not good at all.
Not that you All right. Is there any other troubleshooting calculator stuff I can assist with? I want to make sure they were all functional, so when you do your homework, you can do it. Okay, so in this problem, let's just wrap it up here. What does X stand for? X. Just X.
Variable.
What variable for what? What's varying? Absences. What's Y stand for? Final grade. Okay, so if I wanted to know what's your grade if you have 12 absences, what would you do? 12 for X. What if I wanted to know how many absences can you have if you want to get a 95% in the class? 95 would be Y, and you solve for X. Okay, good, great. All right, so I have great news for you. Are you ready for your great news?
Yes.
On our calendar, I had 2-3 for 3 days, and we just got it done in 2 days.
Wow.
So that means tomorrow you have earned yourself a Math Excel work day. We're not going to do it okay. So tomorrow you get work time. 2 Math Excel is due on Friday. 2 line Math Excel is due on Wednesday next week. You got a little time on that one. One more thing. We have a quiz coming up on Monday. Monday is your first quiz. Here's the details. It's over the first 3 sections. No notes. Basic calculator. You are allowed to work with a partner. And I will let you work with whoever you want. If you want to do it individually, that's okay. But if you want to work with a partner, you may do it. So partner, no notes, basic calculator, Monday first quiz. All right, so work day tomorrow, Monday quiz. Questions on that? Awesome. All right, we'll do cell phone lotto and we're all set.